Hello everyone and welcome back to my channel. So today we are doing analytic geometry. Now analytic geometry is just like trigonometry. What I mean by this is that people tend to have a fear of it. But once you just know these basics, then it's very easy. Okay, so analytic geometry has certain formulas. First, we have the distance formula. That is the formula that you would use to, say, find the distance between point A and point B. Okay, now remember that analytical geometry uses coordinates. And each coordinate has an X and a Y. Okay, value. So, with the distance formula, you can name them like this. This is x1 and x2, or this can be x1 and x2. It really doesn't matter. So you use your x2 minus your x1 squared plus your y2 minus your y1 squared, and you in a square root, sorry. And then you would find the distance between those lines. Okay. Okay. We can also calculate the slope of a line. Say this line right there, you want to calculate its slope. Then you use your y2 minus your y1 divided by your x2 minus your x1. Okay. Now, parallel lines. Okay. This is very important to remember. When you have parallel lines, let's say A, B, C, and D, and they're parallel, it is always necessary to remember that the slope of AB as well as the slope of the slope of CD is equal to each other. Okay. So let's say you calculate the slope of AB and it's 2, then the slope of CD will also be 2. Okay. Now, let's look at perpendicular lines. Okay, let's just say AB again. The slope of AB times the slope of CD would give you -1 once you multiply those slopes with each other. Okay, it should give you -1 when they are perpendicular. Okay. Now they can ask us to find the coordinates of, say, it's usually like this: A, B, and point C. A has an x and a y value, B also has an x and a y value. And they want you to find the x and the y value, the coordinates of point C. Point C must be in the middle of the line. Then you use this formula. Your x, you can number it again, x2 or x1, or you can even number it as xa and xb. It really doesn't matter. So you add the two x's divided by 2, add the two y's divided by 2, and then you would get the coordinates. And this is a new one, the inclination. Now the inclination is when they give you a say like that, and they give you, and let's draw another one and maybe another line, and they ask you to find that value, then you always work from your x-axis. Okay, first you must get the slope of this line, let's call it AB once again since it's so in fashion. So you determine it from the x-axis until the line, that slope you're going to use. So it's pointing in that direction, so you're going to use this line. And then you find this line's slope, and then you say the slope was 2. Okay, let me write it here. Say the slope, you calculate that the slope is 2. So then you're going to use the formula. M is tan theta. So you're going to say your slope is equals to tan theta. We want our theta alone. So we're going to take our tan over. So it's going to be like that. And then you find the value of theta. Or you can use alpha. When they give you alpha, you should write alpha. Okay, let's look at a quick example. Given this graph here, the distance between point C and point A is called B. There is alpha. They didn't give us that value, and they didn't give us the coordinates of C. Okay, now let's look at the first question. Find the coordinates of C. Okay, now which formula are you going to use for coordinates? Find the coordinates. This one. Okay. So here's a trick. Write down the coordinates that they gave you. Okay. Or the coordinates that is on the line of the point that you have to calculate the coordinates of that point. So you are going to use point A and point B's coordinates. Point A is 2, 11. Point B is -4, -5. Okay, now let's name them. Let's say this is X. Okay, I'm going to say X, A, and B because I think most of you uses X, A, and B. So it doesn't matter which one you use as A or B. So let's call that one XA, this one XB, YA, and YB. Now let's write down the formula. They want point C, so you're going to use XB or XA plus XA or B, it doesn't matter which one, and YA plus YB divided by 2. Okay, now all that you do is you substitute. Okay, so let's say YB is -4, so write -4 plus YA is 2 divided by 2. YA is 11. I'm sorry, that's X. I think I said Y. So you're going to say 11 plus YB. YB is -5 divided by 2. And then you would see that the coordinates would be, okay, let's just write this out. It's -2 divided by 2, and that is going to be 6 divided by 2. And thus you would see that the coordinates of point C is -1 and 3. Now we can just write it in. It's -1 and 3. You can also check if you're correct. Look at where this lies, your X. It is laying on this side of the line, on the negative side of the x-axis. So you know your X is correct because it's negative. And you see that your Y is above the line. So it's the positive side of the y-axis. And 3 is positive. The y point is positive. So then you know you're right. Okay, now they want us to calculate the distance or find the distance of B, that distance there. So which formula are you going to use? The distance formula. First, what's the trick? Write down the coordinates that you have. Now, you have A, B, and C's coordinates, so it doesn't make a difference which coordinates you use. Let's use let's use A and C's. So A and C, A was 2, 11, and C we calculated was -1 and 3. No, sorry, you can't use B. Why? Because this distance is B. That distance there is B. And on which 2 points does it include? It includes point A and point C. So you use point A and point C. Sorry for that. Okay, now you can just rename it again. XA, YA, XB, YB. Okay. Now the distance formula is D is equals to the square root of XB minus XA squared plus YB minus YA squared. Okay, now XB was -1, -2 squared plus YB was 3, -11 squared. So thus meaning that the distance between A and C, or the value of B, just write B for in case, is then equals to 8,54. Okay, next question. Find the slope of line AB. So they want us to determine the slope of line AB. That one there. So yet again, write down your coordinates. You have A and you have B. A is 2 and 11. B is -4 and -15. Now, what is our slope formula? Slope is x2 minus x1 over y2 minus y1 over x2 minus x1. So yeah, let's just use A and B again. So that's XA, YA, XB, YB. So our slope is equals to YB minus YA divided by XB minus XA. Now our YB is -5, -11 divided by our XB is -4 minus our XA is 2, which means the slope of line AB is equals to 1,5. Last question. Find the inclination of alpha, or the value of alpha, but you're going to use the inclination formula. So firstly, let's go back to our graph. Where's alpha? There's alpha. There is no x-axis going through there. There's the x-axis. But luckily, we are allowed to draw one. So draw your own x-axis right there under alpha. And then from that axis to that point is alpha. So then we can write, and we, of course, it's pointing toward line AB. So we're going to use the slope of AB. Okay. So what is our formula? Our formula is slope is equals to tan theta. Okay, but we don't want theta now, we want alpha, but it doesn't really make a difference. So what is the slope of AB? We determined that was 1,5. So it's 1,5, and guys, you have to write this formula, okay? Otherwise, you're not getting marks. 1,5 is equals to tan alpha. We want alpha alone, so we take tan to the other side. So it's going to be the inverse of tan 1,5. So that means that alpha has a value of 56,31 degrees. Thank you guys for watching this video. I hope you guys understand analytical geometry better. Until next time.